pmode command is going to be removed in the near future releases of MATLAB, or at least it will not be supported. So we are not going to dwell on it for too long. However, I nevertheless like to demonstrate it quickly in order to give you an idea of how the client and the workers operate and interact with each other. So the syntax of the pmode command is as shown in this slide. Pmode start, and you can have the cluster profile name and the number of workers from the cluster profile that you are going to start the parallel mode working with. Of these, the profile name and the number of workers are optional. If you don't specify them, it will just be the default clusters will be started with default number of workers. And when you finish working in pmode context, you can use either pmode exit or pmode quit to get out of it. And you'll see later on that each worker will have its own workspace, and the only thing you can't do on the workers is, of course, as we know, graphics. So any commands relating to graphical output in the workers command window are going to be ignored. So here is a sort of visual display of interpretation of how the client and the workers will be working in pmode. You have the command window for the client. So this is really a standard MATLAB as we started up our client and the command prompt. When you start a pmode mode up, then you'll end up with a parallel command window, and there will be separate windows for the workers as well, so that you now have the option of interacting with the client by typing commands on the client's command window, or interacting with the workers by typing commands on that command window. As for communication between the client and the workers, we are going to see it in the next slide. But as before, as with SPMD, you still have that lab index being unique to each worker. Apart from that, when you type a command in the parallel command window, it will be executed by all the participating workers in parallel. So these are the commands for moving data between the client and the workers when working in pmode. So you have got basically lab to client, pmode lab to client command to transfer data from the workers onto the client's workspace, or you have the pmode client to lab to do it the reverse, sending the data from the client to the workers. So you can, with the lab to client method of pmode, you have the next parameter will be the variable name in the workers space, workers workspace, and then the worker index, and optionally you can rename the actual variable that is being transferred to the client in the client's workspace give it a different name. So that's an optional parameter. And the other way, you can move variables from client to the workers. Again, you have client to lab, client, the variable now, this time the name of the variable in the client's workspace. And the workers, you can specify one or all workers. And optionally, again, you can rename those variables when they get to the workers workspace as something different. So here are examples as well for both of those commands. In the client to lab example, we are transferring myC variable from the client's workspace into the workspace of workers 1, 2, and 3. And when they arrive there, they will be named as myW. There are some practicals for this section of the course as well. I recommend you attempt these practicals, particularly the last one, for example 6C, because the P mode is going to disappear soon, and it gives you an example of how, if you had done anything in P mode, to transfer it into an SPMD structure instead. So let's have a quick look at the way now the P mode works. P mode. I'm going to use the default cluster, so I can simply say start, and that will start up the default number of workers on default cluster. Remember, we are in the client. We are always in the client when we just first start MATLAB. And it's already giving us warnings that P mode will be removed in the near future. So it's telling us that it is busy trying to create a pool. I'm going to resize this window because soon we're going to have other windows. Here we are. We've now got the window of the parallel workers cluster. And we've got the prompt here. P. So you can type. So now we have got the client here. I can type anything. For example, let's see what pi is. And you can type the same thing or add something different here. Let's see what epsilon is. So I think these are built-in functions. So you can see that the prompt command here, any command you type here is going to be executed on all the workers. We've got 1, 2, 3, 4 workers. It says log 1, 2, 3, 4. And whereas in the client, so we really now have sort of two MATLABs. One of them is the client here, and the other one is the workers. When we issue a command here, it's just executing the client's workspace, whereas on the parallel pool, it executes on all the workers. So I could check what lab index is. This will be the only thing that will be the different on the So you can see lab index is 1 for the first lab, 2 for the second lab, so on. So I'll just show you one more thing. So let us say index is equal to, or IND is equal to num2str string lab index. Okay, so I am converting the lab index into a string, and then I can let's form another variable. File name is equal to serial, no, serious, comma int. So I've now generated file names on the workers. They go a series 1, series 2, 3, 4, so in each worker. Now I can now use the load command, load file name. I think this should work. Okay. Who tells me what I have loaded Y from the series things, each of them we've got, but because we have loaded in each worker a different data file, which is here, series 1, 2, 3, 4. These were data files that were storing some variable called Y, but they are different now. If I was to, for example, let's say Y, let's see what the size of Y is to start with, Y. You can see they are all different sizes of series, 123 elements long, whereas the second one is 92 elements long, so on. Right? So you can see that we can now load in different data, and then we can perform calculations on those different data. So they'll all be running in parallel, you see. We will be referring to Y in our calculations here, but when we refer to Y, each Y is going to be a different Y vector, which was read from those saved data files. So you can see that parallel working in this fashion is possible. Of course, unfortunately, as I said, the pmode is going to be removed, but nevertheless, this method of working is still transferable to SPMD structures, and the par example 6c is going to show you what we were doing here, basically how it can be converted to SPMD structure, so that you can perform the same things you performed before in pmode when pmode disappears. I think we are going to stop here, and I'd like you to perform those par examples A, B, and C to get a feel of how the parallel working is going. Although pmode is going to disappear, this gives you a sense of the way the MATLAB runs and how the workers run in parallel. This was one of the last sessions of the part 1 that we are covering. We are now in the second part going to start performing our examples on the HPC clusters, and we shall be working more with jobs and tasks. So, okay, we'll end it here now.